Good evening, everyone. Good evening, Shruti, Vishal, Sharmila, Rahul, Ekta, Divyashri. Good evening, beta. Shall we start the class now? Fine. So morning I taught you something about electrons. I just want to know about who has done the discovery of electron. Start telling the answers. Who has done the discovery of electron? Come on. Start answering the question. Who has done the discovery of electron? Who has done the discovery of electron? Discovery of electron. Who has done the discovery of electron? Who has done the discovery of electron? Discovery of electron. Civil 13A. Good evening. Who has done the discovery of electron? Come on, start answering the question fast. J.J. Thomson. Absolutely correct. Then I was asking morning, I have discussed something very important in morning class. Ashwarya, good evening. In morning class, I discussed about charge by mass. Charge by mass. Okay, charge by mass of an electron. Charge by mass of an electron. Who has done the discovery of that? Who has exactly found that charge by mass of electron? Write the name of that. Who has found the charge by mass of an electron? Come on, quickly tell me. Charge by mass of an electron. Charge by mass of an electron. J.J. Thomson is the correct answer. J.J. Thomson is the correct answer. Charge by mass, J.J. Thomson. Absolutely correct. Then charge of electron. 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 Morning itself we have finished. Charge of electron. Absolutely correct. Millikan. Millikan has done. And what is the experiment? What was his experiment was actually? What was his experiment? What was his experiment? Millikan's experiment. Millikan's experiment. Yes, Millikan's experiment. What was his experiment? What was Millikan's experiment? See, oil droplet experiment. Absolutely correct. Oil droplet experiment was the experiment with the help of which he just found the charge of electron. Okay, what is the mass of electron? Morning class we have finished everything. What is the mass of electron? Come on, quickly tell the answer. Oil droplet experiment is the correct answer. What is the mass of electron? What is the mass of electron? Yes, he took the charged particles and what he did is he took droplets, oil droplets, and then he just charged the oil droplets, and between two electroplates the oil droplets were moved, and its speed has been exactly measured, and that was the experiment what it is worked. I am talking about mass of electron, Shruti. I am talking about mass of electron. Mass of an electron. Mass of electron 9.1 into 10 to the power minus 31 kg. That is the correct answer. That is the correct answer. Mass of electron is 9.1 into 10 to the power minus 31 kg is the mass of electron. That is the correct answer. What is charge by mass of an electron? Charge by mass, because I have told you that morning itself I have informed you that evening I am 100% going to ask questions related to it, and then only I am going to talk about protons. Okay, so what is, come on, quickly start answering my question. What is charge by mass of an electron? Charge by mass, I am not talking about charge. Charge, I know that you will be giving the answer for charge. I am asking charge by mass. 1.76 into 10 to the power 11. Absolutely correct, Vishal. This was exactly we have discussed coulomb per kg. Yes, the unit is also important. Charge by mass of an electron is 7.6 into 10 to 1.76 into 10 to the power 11 coulomb per kg. Absolutely correct. What is the charge of electron? What is the charge of electron? Now if somebody will be asking you what is the charge of electron, now you can answer it. 1.6 into 10 to the power minus 19 coulomb is the charge of electron, and this is what we have discussed in morning class. Now in evening class we are going to understand that what is exactly proton and who has discovered proton. I think morning itself I gave a small introduction about proton. Can you tell me about proton? Come on, quickly tell me about proton. Who has done the discovery of proton? Who has done the discovery of proton? Who has done the discovery of proton? Come on, come on, come on, do it. You can give the answer. Very good, Vishal. So that was a quick fire round, and exactly, Vishal, correct. Goldstein has done the discovery of proton. Einstein, Keshav, absolutely correct. Avinash, absolutely correct. Shrutika, Kanishka, Sharmila, Rahul, absolutely correct. Now, my next question. I am going to stop myself. I am going to ask the next question from you. Okay. Golden natural sign. Hello, golden natural sign. Nice name. Okay, golden natural sign. That's really super name. Krisha, Goldstein is absolutely correct answer. Goldstein is absolutely correct answer. Now, my next question is, what is the symbol of electron? What is the symbol of electron? Yes, beta, Goldstein is the correct answer. Goldstein, Shine, I am going to call you Shine. Shine, answer is absolutely correct. Goldstein is the correct answer, beta. Now, I am just going to ask next question from you. Next question, what is the symbol of electron? Morning itself we have finished. Symbol of electron? Yes, 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 absolutely. Negative. Electron is negatively charged, but electron is presented like this. Okay? Electron is written like this. It is presented. The symbol of electron is this. The symbol of electron is this. Fine. Now, oh, Shikha. Shikha, you changed your name. Huh, Shikha? You changed your name. Yes, absolutely correct. Now, we are going to go towards about proton discovery. Now, I discussed another important point in morning, and that point was about electrical neutrality. What does electrical neutrality means? Come on, type and send me the answer. Good evening, Jiva. Type and send me the answer. What is the meaning of electrical neutrality? What is the meaning of electrical neutrality? What is the meaning of electrical neutrality? Come on, come on, come on, you can answer the question. What is the meaning of electrical neutrality? Electrical neutrality means, okay, no problem, Jiva, just answer the question, beta. What is the meaning of electrical neutrality? What is the meaning of electrical neutrality? Positive charge equal to negative charge, absolutely correct. In short, you have told the correct answer. Positive equal to negative, super Keshav, Sharmila. The number of electron and proton is same in an atom. Yes, beta, Shikha, but electrical neutrality here, when they were discovering, see, there was one concept that number of positive charge equal to number of negative charge. Number of positive charge, I am repeating this point, number of positive charge equal to number of negative charge. So this was exactly talked about electrical, means the whatever matter is there, atoms are there, they are electrically neutral. They are electrically neutral, means number of positive charge equal to number of negative charge, and that is exactly the case of electrical neutrality. That is the case of what? That is the case of electrical neutrality. Number of positive charge equal to number of negative charge. I hope you might have understood this point. Number of positive charge equal to number of negative charge. So this was the point of discussion we have exactly discussed in morning class. Now, we are going to talk about Goldstein experiment. So before discussing about Goldstein experiment, let's see what type of discharge tube he has taken. See, Ekta, when they are having negative charge in an atom, then there should be positive charge with equal amount. Yes, beta, it should be like same, beta, it should be like same. Number of positive charge should be equal to number of negative charge. Number of positive charge equal to, that is cathode was made, hold, yes beta, that is exactly perforated cathode we have talked about. We talked about perforated cathode. What we have talked about in morning? We were talking about perforated cathode, means two different type of electrodes we have taken, but perforated cathode has been taken. Now we are going to understand how they have exactly discovered about proton, how they have discovered about proton, how the Goldstein experiment was so successful in explaining about proton. The first important point is that we know that atoms are electrically neutral. That time also, when the discovery of electron was done, after discovery of electron, there was exactly a conception that if negative charge is there, then equal amount of positive charge must also be there. If negative charges are present, then equal amount of perforated cathode is used. Absolutely correct, beta. So that is, if negative charges are there, then equal amount of positive charge must be also there. And before that theory, he has exactly taken a perforated, or what you can say perforated cathode he has taken. Fine. Now we know that given amount of gas, see, change of gas in the discharge tube you can do, but cathode ray will be discharged. That we have already understood in the previous experiments. Fine. Another important point is that when we are talking about anode, the cathode ray travel from cathode to anode. This is exactly the fact. But now what we are doing here is to understand about proton. What we have done here is we have taken perforated cathode. Now in between the cathode, because always what has been done, that cathode used to take the rays out and the rays was exactly absorbed at the anode and the light was emitted on the back portion of the anode. But this time what we have done, we took perforated cathode. Now this perforated cathode, okay, this perforated cathode allows the anode rays to go to go opposite of cathode. You see here, to go opposite. So anode rays, these red dots are indicating the flow of anode rays from anode to this side, opposite of cathode, and see the black dots are exactly indicating the motion of cathode rays. So this is exactly the concept, and the discharge tube started illuminating in the opposite direction of anode. It started illuminating in the opposite direction of anode. So this was the concept. This was the discovery what they have exactly done. So now we have to understand exactly, is the anode emitting the anode rays? Like the way we are talking about cathode are emitting cathode rays, anode is emitting anode rays. No, the anode is not emitting anode rays. This is a very important point. This anode is not emitting anode rays. I am stick to my point that this anode is not emitting anode rays. And this point I want my children to remember very nicely. I am going to explain about it. Now, origin of anode rays. What is exactly the origin of anode rays? Everyone has to understand. So I am underlining the most important point. First though, last class I think someone told that cathode rays are canal rays. No, cathode rays are not canal rays. The anode rays, which is positively charged, they are called as canal rays. So now if somebody will ask you why the anode rays got the name canal rays, then the answer is the anode rays got the name canal rays because they are exactly passing through the perforated cathode. They are passing through the perforated cathode. They are exactly passing through the gaps of the cathode and going in the opposite direction of anode. That's why it is exactly, since it is passing through the holes of the cathode ray, that's why it got a name called as canal rays. That's why it got a name called canal rays. We will see a little light when this light will be coming. Yes, but this light will be exactly coming in this direction. Okay, opposite. This light will be coming in the opposite direction. Everyone pay attention for this point. This is very, very important point I am discussing. Why anode rays got the name canal rays? Cathode rays got the name canal rays. Anode rays got the name canal rays because the anode rays passes through the perforated cathode. Because of that, it got the name canal rays. Now Keshav, Vishal, confusion over. They are named as canal rays because they pass through the holes of canals in the cathode. Further, this deflection in an electric field shows that they carry positive charge. So anode carries positive charge. That was the one important point. Since the anode rays are passing the perforated or holes of cathode, that's why the anode rays, another name is canal rays. Come on, quickly give me a hands up that you have understood this point. Come on, quickly say that you have understood this point. Why anode rays are called as canal rays? Yes, I am going to discuss about production of this light also, Shikha. I am going to discuss about the production of the light beta. I am going to discuss. Now only I am going to discuss this point, that how this light has been emitted. Just till this point, I hope everybody understood. Till this point, I hope everybody understood. Till this point, come on, quickly tell me, you understood till this point or not? Everyone, come on, quickly say me. You have understood till this point? Yes, Sharmila understood. Super. What about others? Others understood? Super, Sharmila. Now, Shikha understood. Very good. What about others, Shruti? Yes, Shrutika understood. Because I really want everyone to understand this point. I want everyone to understand this point, because without understanding, yes, Vishal. Vishal, I was just discussing, Vishal, a very important point, that why cathode rays got the name anode rays got the name canal rays. See, anode rays got the name canal rays because they are passing through these holes of cathode, so that's why they have got a name called as canal rays. They have got a name called as canal rays. So if somebody will be asking you this question, that why anode rays are called as canal rays, then you can explain this point. Come on, you can explain this point now. Cathode, perforated cathode we have taken, and anode is traveling from this side and passing through this hole. You see these red arrows are exactly passing, and because of this, what answer we have given? We said that since it is passing through the holes of the cathode, that's why the name is got canal rays. So anode rays are also called as canal rays. I repeat my point, anode rays are also called as canal rays. I hope you might have understood. Anode rays are also called as canal rays. Come on, if you have understood this point, then we will go for the most important point. Now, first thing is that why light is emitted. Okay, second important point here is that Keshav understood, Vishal understood, anode rays do not originate from anode. This is a very important point. Morning itself I was about to discuss this one, that anode rays, people think that this is cathode, this is anode. So cathode rays are coming from cathode and anode rays are coming from anode. That is the general conception people will think about, that anode is releasing anode rays. Anode is releasing anode rays. This will be a general perception. Everyone will think like that only. Yes, come on, you will think like that only, na? That auntie said like cathode rays are exactly eliminated from cathode, so anode will be eliminated from anode. But it is not the fact. Now what is the fact actually? Anode rays, Shika, your answer is here only. Shika, just check this point, beta. So anode rays do not originate from anode. They are produced in the space between the anode and the cathode. That means we came to know that the anode, okay, yes, we came to know that we were thinking that this is cathode and this is anode. So cathode rays are coming from cathode. So anode rays will also be coming from anode. Anode rays will also be coming from anode. But this conception got proved wrong. This conception got proved wrong. Now they are telling that no, anode rays are actually not coming from anode. Then what is this on anode rays and how it came? Then we have to understand a very important point, that is how this anode has been obtained and why it is exactly casting light. Okay, casting that color. Now this you have to understand, they are produced in the space between anode and cathode. It is believed that the high electrical energy supplied between the electrode splits the molecule of gas present in the tube into atoms. I'm going to explain this one very in depth. The electron present in these atoms further absorb electrical energy and are knocked out. The electrons thus knocked out travel towards anode and from a part of cathode rays. The remaining part of the atom becomes positively charged particles. These positively charged particles travel in the form of stream towards the cathode. Okay, and that's why they are exactly casting color in the cathode side. That's why they are casting color in the cathode side. So I know that my children did not understood, so I have to draw it and explain. Now understand this thing. Two things are happening in the discharge tube. One thing is this is cathode and this is anode. So now we have exactly taken anode for this experiment. We have taken anode this side. So this is exactly what? Anode. And this is perforated cathode. Now exactly what happens here, beta? Now a very high amount of current is exactly passing. Yes or no? Now one electricity of 10,000 volt is passing along the electrodes. Then what is exactly happening there? That this is exactly filled with a particular gas. Yes or no? So this discharge tube is filled with a particular gas. So now the gas are not isolated, they are molecules, gaseous molecules. The discharge tube is filled with gaseous molecules. Okay, of specific, and there is a pressure maintained in the discharge tube. There is a pressure maintained in the discharge tube. Fine. Now what is happening? The gases which is present, the gaseous molecules, I repeat, the gaseous molecules that is present in the discharge tube, when current will pass when this high amount of current, so these current will give energy to this gaseous molecule and they will break the molecules into atoms. That means the molecules will break into atoms. Arif, good evening beta. Good evening Arif. So they will break the gaseous molecule in the discharge tube into what? Into atoms. Now what will happen to the atoms? First, the gaseous molecule, because of the passing of high current, this current is exactly first breaking the gaseous molecule into atoms. Now the atom's outermost orbit, electron will get exactly knocked out. Means the outermost electron of the atom of the gas, the gaseous atom. First the gaseous molecule was there. Now this gaseous molecule, good evening Arif, how are you beta? The gaseous molecule first will get converted into atom. The gaseous molecule will get converted into atom. Now this atom, electrons will be present in the outermost orbit. Now due to this high amount of electrical energy, these electrons will be knocked out. So when this electron will knocked out, now this will not be atom or element. Now it will become ion. Now this will become positive ion. Now the electrons will start traveling towards anode, but these positive ions they will have to move in opposite direction. These positive ions will start traveling towards cathode. So these positive ions, it will start. Very good Arif. Now beta, these positive ions will start traveling in opposite. So now we know that cathode and anode. So cathode and anode, they will be exactly behaving differently. Anode is positive, cathode is negative. So now this positive ions, that is positive ions, gaseous ions. I am talking about gaseous ions, Sikha. Everyone remember this point. I am talking about which one beta? I am talking about gaseous ions. So these gaseous ions will start traveling from positive side anode towards the cathode, and because of that beta, color will be eliminated here. Sorry, color will be, this part will be eliminated. So that in the case of Shikha, I think, did you join that class beta Shikha? Previous video I have explained how cathode, in cathode nothing you have to do. So you have to take anode this side and you have to take cathode this side, and we have exactly discussed already in that at pressure, any gas you will take at pressure of 0.001 mm, the cathode will start eliminating, the cathode will start releasing cathode rays, and since this cathode ray will travel from cathode towards anode, so opposite side of the anode will start exactly illuminating with greenish yellow color, that is yellowish green fluorescent, it will start illuminating beta. and that is exactly showing that ki cathode rays is coming. And then material property also we have discussed. Just see 2 previous videos, you will be able to understand the entire part of it. Just 2-3 videos are there beta, where I have discussed this, starting from structure of atom videos. Now if you will see, you will understand the entire part of it, because I have discussed everything in much details there. Okay, so now just see 2 days back video, means tomorrow 2 videos, day after tomorrow 2 videos, just 4 videos, and today I think 5th. So 5-6 videos are there. If you will see that, you will understand everything. Okay, now beta, tell me, did you understood this one? So what we have discussed, we understood a very important point, that ki here in between this region only, in between this region only, what happened, the gaseous molecules will first broke into gaseous atom. Okay, they got converted into atom, and because of current, high amount of current passing through it, the atom, electrons from the outermost orbit got knocked out, and electron become released. So this electron is negative charge, so this electron started traveling towards anode. Okay, and that means cathode ray started traveling towards anode, but the atom, after releasing electron, became positive ion. The atom, after releasing electron, became what ion beta? Positive ion. So this positive ion will travel opposite to cathode, this positive ion will start traveling towards the cathode, I said opposite, towards the cathode, opposite to anode, and they will cast the color here. Okay, and they will cast the color here. I hope you might have understood this point. Come on, quickly tell me, did you understood this point? So key point, Shika, key point is gas molecule got converted into gases. Atom knocked out the electron from the outermost orbit. The electron became free, and they started moving towards anode. And the ions means the atom which has released electron will now become positive ion. The atom which has released electron will now become positive ion, and these positive ion started traveling towards cathode, and it will exactly cast color in the opposite of anode. It will cast color in the opposite of anode. This is a very important point beta. Means you will have to go here and there, such many books, and then so one very small part I have discussed. Anytime if anybody will ask, you just say that, hey, don't think that anode is releasing anode rays. It is not the anode which is releasing anode rays. It is the internal part between cathode and anode. When current will pass, the gaseous molecules will break into atom. Then atom outermost electron will be knocked out because of the current. And this electron is negatively charged, so negative will fall towards positive. So electron will go towards anode, but the atom which has taken out electron will become positive charge. So positive will go towards which direction? Positive will go away from the positive part. So it will start going towards cathode, and that's why the color will be exactly casted opposite of anode. I hope you might have understood this point. Very good, Shika. So if somebody will be telling you, don't trust those points, just say that this is the fact. This is the fact and this is the point. Okay, and just clear the concept of anyone, your classmates, everyone. I'm telling, clear the concept. If they have confusion, you clear this point out, that no, this is not the case, this is the actual case is this one. So that means beta, they travel in the form of stream towards cathode, and it is exactly constituting anode rays. Now we are going to talk about properties of anode rays. Now we are going to talk about the properties of proton, because anode means positive charge. Now these positive charge must possess some properties. Now shall we start discussing about the properties of this? Now first property is they travel in straight line. Now can I revive the old concept? in the old concept when we were discussing about cathode rays, then at the time of discussing of cathode rays, what we have seen, that cathode rays travel in straight line. Now they are telling that anode rays are also traveling in straight line. Anode rays are also traveling in straight line. How we came to know that cathode rays are traveling in straight line? So what we have done is, we kept a what you call metal plate in between the cathode rays. Now this metal plate casted shadow here. So I told you that day that light cast, when light is traveling in straight line, then it casts shadow. So light is traveling in straight line, beta. Since light is traveling in straight line, so it is casting shadow. It is casting. So that means light travels straight line, casting shadow. That means cathode ray is also traveling in straight line. If it is following the path of light, that means cathode rays are also traveling in straight line. And since cathode rays are traveling in straight line, it is casting shadow. So when cathode rays can cast shadows, can you talk about anode rays? Can we talk about anode rays, beta? That means if we are going to keep a metal plate here, if we are going to keep a metal plate here, now this metal plate, because the anode will also travel in straight line, the anode will also travel in straight line, because the property says that anode are also traveling in straight line. So since anode is also traveling in straight line, so it will cast shadow here. It will also cast shadow here. So by checking that one, so what Goldstein did, Goldstein do not have to do a big work. He just kept a metal plate here, and then what he saw one shadow is exactly formed here. Then he exactly said that unlike cathode rays, anode are also moving in straight line. Anode is also moving in straight line. Come on, Bacha Party, come on, quickly tell me, did you understood this point? Understood this point, yes or no? We don't have to do big work here, beta. We just understood one simple concept, and with that only we proceeded that point and understood that ki like cathode, when they are traveling in straight line, they cast shadow. Anode rays also, in between that, if we have kept a metal plate, it is also casting shadow. Where is Vishal, Sarmila, everyone? Understood this point? These points are bone of properties of proton. Okay. Next property, they are saying that they are made of material particle. Hey, we have done this also, na? We have done this also in cathode ray experiment. In cathode ray experiment, what we have done? We just kept a mica made plates or wheel. Just fix a wheel here. Okay. In that previous experiment, what we have done? Yes, correct, Shruti. In the previous case, what we have done? We kept a wheel, na? And when cathode was there, that from the cathode rays, from the cathode, the rays were coming. And what the rays did? The rays started coming from cathode and going towards anode, started rotating the paddle. So paddle started rotating. The paddle started rotating. So the paddle was rotating because this material particle has the property to strike the blades and rotate the blades. So something which is having the particle character, they can only have the capability to strike and rotate. If it is not a particle, then how it can strike and rotate? Not possible. If it is not a material particle, then how it is going to strike and rotate? Not possible, na beta. So here also the concept is very clear that this material particle was exactly doing what? It was exactly striking the blade and rotating it. So we came to know that like cathode ray travel in straight line, anode rays also move in straight line, and they are also material particle. They are also having what? Material particles. They are also having material particles. So this is the next concept we have understood. Next property is they carry positive charge. It's the self-driven concept. See, they are moving towards which one? It has some mass. Yes, beta. Proton is also having mass. Proton is 100% having mass. Like electron is having mass 9.1 into 10 to the power minus 31 kg. In the same way, proton will also have mass. So, we are going towards the next point, that they carry positive charge. 100% they carry positive charge, because now only we have seen that whatever ions were there, the positive ions were there, they started traveling towards cathode, perforated cathode. So, their travel towards perforated cathode is exactly a proof that they are positively charged. Okay, so they move towards cathode. Yes, so Shruti, that is absolutely better. Since they are moving towards cathode, it is proving that they are exactly positive charge. So let's see for studying deflection. So, or also you can do one thing. If you want to have a concrete proof, if you want to prove it in a very solid way, then you say that I am going to keep an electric field here. Keep an electric field here. Just allow electric current to pass through this region and then keep an electric field here. So what electric field? The positive terminal will be there and negative terminal will be there. So just take one anode this side. So then one hole will be there, and from this hole the light will start moving. Now the light, the anode rays will start moving. Now these anode rays will start deflecting towards negative. So after passing this region, the anode rays will start deflecting towards negative electron. So the deflection of anode rays towards the negative terminal, it is showing that anode rays are positively charged. It is showing what, beta? It is showing that anode rays are positively charged. Come on, quickly tell me, did you understood this point? Did you understood this point? Everyone, come on, quickly tell me, did you understood this point? Did you understood this point? So if I am going to keep electric plates here, if I am going to allow current to pass through this, now this plate, one terminal will become positive, one terminal will become negative. Now when the anode rays will travel, then this anode rays, after passing this plate, it will exactly started deflecting towards negative. So deflection towards negative is proving one part, that anode rays are positive. Then only its affection towards negative is going now. Then only its affection towards negative is going. I hope you might have understood this point. So they carry positive charge. We understood that they are carrying what? They are carrying positive charge. We understood that they are carrying what charge? They are carrying positive charge. They are carrying positive charge. They are carrying which charge, beta? They are carrying positive charge. I hope my bacha party have understood a very typical part of it. Now we have understood back to back the properties of proton. So properties, like properties of electron, properties of proton are also same. That is, electrons are exactly moving in straight line, means cathode rays are moving in straight line, anode rays are also moving in straight line. Second important point is, cathode ray contains material particles, anode ray also contains material particle. But now here only one difference is there. Cathode rays are negatively charged, anode rays are positively charged. Okay, what is the other name of anode rays? What is the other name of anode rays? I have discussed now only what is the other name of anode rays. What is the other name of anode rays? Let's see who will answer this first. What is the other name of anode rays? Yes, Super Shruti, the other name of anode rays is canal rays. It is exactly canal rays. Yes, it is exactly canal rays. The correct answer is canal rays. I think we have discussed this point. The correct answer is what, beta? The correct answer is canal rays. The correct answer is canal rays. The other name of anode rays are canal rays. Super, fabulous piece of work. Okay, so now we have understood about proton. I think my children will be able to answer all the questions whatever will be coming in examination, because they've understood the content related to it. Now, determination of charge by mass of positively charged particle present in anode. So first we have understood that positive charged particles are present in anode. What is present in anode? Positively, hi Kanishka. Kanishka, now only you have joined, beta. Are you all right? Correct only, Shika. You are absolutely correct that if we will see it nicely, then we will come to know in the first experiment itself, in cathode ray experiment itself, we have discussed anode. But beta, that time the concepts were not so neat and clear. There we can do the what you call differentiation of positive, and slowly, the more they learned, the more they understood the behavior of charges, the more they discovered. Okay, that's what beta, you know, after proton and electron, now the discovery of neutron was done much later. They have done the discovery of neutron, and the reason behind is this only, because how much they discovered, now there was a stagnant phase coming, but after that stagnant phase, they were learning that okay, something must be missing in that part, and that for searching that missing link, now they used to again invent, again discover thing. So like this only, missing links they have connected, and with that only now what concepts we are having, that is the most what you call advanced concept. Now so we went to quantum mechanics. Before that, before quantum mechanics, it was like we had enough small information, ideas. From the ideas only we were exactly learning. Okay, now we are going to go towards determination of charge by mass. Now who would find charge by mass? Again J.J. Thomson. So what was the concept here? That by applying method similar to that of J.J. Thomson, concept is coming. So I think I am the copycat, because I'm just taking their concept and teaching you. So I am copycat. But you think about Goldstein. Goldstein has taken the concept of J.J. Thomson. So again concept of J.J. Thomson is coming. Now you see, by applying method similar to that of J.J. Thomson, by studying the extent of deflection of anode, by applying electric field, again they have found the charge by mass. Charge by mass of proton. They have found what? They have found the charge by mass of proton. I hope you might have understood. Charge by mass of proton, and how much charge by mass of proton they have got. What is the charge by mass? So copycat, that is what Vishal, I was not about to say that, so only from my mouth this word came. Again J.J. Thomson. Yes, now because see, he used discharge tube experiment, Goldstein used discharge tube experiment. He took cathode anode, Goldstein also took cathode anode. Only the placement of cathode he changed, and it took the perforated cathode. And after that, whatever experiment Thomson has done, all the experiment repeat telecast were there, and after that repeat telecast, another important point was charge by J.J. Thomson. So Goldstein also found charge by mass, but only one thing is there, the way he got charge by mass, the way J.J. Thomson got charge by mass, same way Goldstein also got charge by mass. What he did, he kept an anode, and in between the anode he kept a cathode hole. He kept a hole in the cathode, and then electric positive and negative terminal of electricity he did. So after taking, why he kept a cathode? So that extra amount of anode will be absorbed, and from this hole only few rays of anode will go. Not all the rays of anode will go, only few rays of anode will go. But when the anode rays are traveling in straight line, what happened? The electric field, exactly in between that rays, the electric field tried to attract the anode. So which terminal will try to attract? See, anode is already positive charge, anode rays are already positive charge. So these rays are already positive charge. Now this electrical terminal, this is negative terminal, this is positive terminal. So this anode will have repulsion between them. but this anode rays will have attraction between them. So after traveling this, the rays started deflecting in this direction. The deflection of the rays towards negative is indicating that anode rays are positively charged. The deflection of the rays are indicating that anode rays are positively charged, and the extent of deflection. This extent of deflection gave charge by mass ratio. It gave charge by mass ratio. It gave charge by mass ratio. So this extent only, the deflection extent only gave the charge by mass ratio. I hope you might have understood this point. The extent of deflection only beta, they gave charge by mass. Same copy concept only beta, no change. Same copy concept, no change there. So you see now, but only one thing is there. Electron charge by mass was 1.76 into 10 to the power 11. Electron was 1.76 into 10 to the power 11 coulomb per kg it was. But you see, charge by mass of proton is much less. It is 9.58 into 10 to the power 8 coulomb per kg. Into 10 to the power 8 coulomb per kg. It is lesser than electron. So the ratio is exactly coming same. Now next is how the charge of electron was there. In the same way, by repeat telecast of Millikan experiment, he got the charge of proton, and what he found that though proton is positively charged, its charge is similar to that of electron. So electron charge is 1.6 into 10 to the power minus 19 coulomb. Electron charge is 1.6 into 10 to the power minus 19 coulomb. So here proton charge is also same. Proton charge is also same. Only proton is positively charged, electron is negatively charged. Electron charge amount is equal to proton charge amount. So if somebody will be asking, this is exactly, this content has been taken from Millikan oil droplet experiment. Okay, so same Millikan oil droplet experiment concept was used there na to get the charge of electron. Same concept that has been used to get the charge of proton, and exactly they came to know that charge of proton is similar to that of charge of electron, but only opposite in sign. So proton charge is 1.6 into 10 to the power minus 19 coulomb, and electron charge is minus 1.6 into 10 to the power minus 19 coulomb. So one will be positive and one will be negative. I hope you might have understood. Then what is the mass of proton? What is the mass of proton? The mass of proton is 1.67 into 10 to the power minus 27. 1.67 into 10 to the power minus 27. What is the mass of electron? Mass of proton 1.67 into 10 to the power minus 27. But electron mass was, how much the mass of electron? Electron mass was 9.1 into 10 to the power minus 31 kg. But proton, you see, 1.6 into 10 to the power minus 27. 1.6 into 10 to the power how much? 1.6 into 10 to the power minus 27 is the mass of proton. Is the mass of proton. So we have seen the mass of proton. Now we have understood one very important thing, that okay, charge by mass of electron is also existing. Charge by mass of proton is also existing. Charge of electron and proton both are same. But electron is negatively charged, proton is positively charged. Electron is negatively charged and proton is positively charged. Now, what is exactly mass of proton? 1U. What is the mass of proton? 1U. How to present a proton? Now you have to understand, where electron is presented like this, proton is presented like this. Okay, proton is 1p1. Proton is 1p1. The symbol of electron is minus 1 E0, but here the symbol of proton is 1p1. The symbol of proton is what? Beta, that is the Millikan oil droplet experiment they have done. The droplet has been taken and charged, and between two electroplates, what they have, with a high amount of current, they are allowed to pass through the droplets. So now these droplets they and then their what you call charge and mass is calculated, and then their charge and mass is calculated. We have exactly discussed this point in morning. So one more time beta, you check this morning video today, you will be able to understand that concept. So now let's see discovery of proton. So just one droplet takes Shikha. Now charge them with electrons, and then the droplet, whatever the droplet is, must be making with some molecule. Now, so if it will be breaking, it will again start traveling, and the intensity with which, or the speed with which the droplet is traveling, with the help of that we were able to get the charge by mass of electron or mass of electron. We were able to get the mass of electron. I hope my children might have understood this point. So the discovery of electron proved that all the atoms are having negative and positive, both the charges, so that so now everybody started searching about positive charge. So they came to know about anode, okay, perforated, and so they came to know about a discharge tube and perforated cathode he has taken. Now when electricity was passed through this tube, a cathode ray were produced in the space between cathode and anode. So the moment electricity started passing from cathode ray started moving, okay. However, at the same time, mysterious rays were also there which will try to hinder it. I hope you might have understood till here. I hope you might have understood. So now in tomorrow's class, because if I will teach more, you will exactly go fuse. So now look here, in tomorrow's class I am going to talk about charge and mass of proton. In tomorrow's class we are going to talk about charge and mass proton. Now itself I am informing, tomorrow 5:55 class will start sharp, and from tomorrow we are going to discuss about discovery of neutron, and then we are going to discuss about Thomson's atomic model, and then we are going to discuss about which one? Thomson's atomic model. So we are going to keep it till here. Bye everyone.